Today's notes are on trigonometric functions, section 4-4 in your textbook. And the very first definition today is what's called a reference angle. So what a reference angle is, let me make a sketch here. So let's just say you have a 150 degree angle. 150 degrees, we start here, we go almost all the way to that straight line, and here's your 150 degree angle. Now what a reference angle is, if you're finding, let's say, the sine, cosine, or tangent of a 150 degree angle, it's much easier to look at this angle down here. So I'm going to mark this with a theta with a little prime by it. So theta prime is this reference angle. So what a reference angle is by definition, it's the angle formed by the terminal side of your angle and the x-axis. So your reference angle might be here. If we have, let's say, a bigger angle, let's say we have like a 220 degree angle, which takes you somewhere down here. The reference angle would be this one down here, so I'll call that theta prime. So the reference angle is always formed by the terminal side of your angle and the x-axis. Okay, so now that we know what a reference angle is, let's move on. First example, we're given if tangent of theta equals -5/4 and cosine of theta is greater than 0, we need to find these 6 answers. Okay, now we need to start with a sketch here. So I'm going to draw a set of axes, and I'm going to try to draw this angle. We know the tangent of theta, so I'm just going to put here, theta is down here. Tangent is -5/4. Now I've just made a mistake because this -5 goes upwards, so we can't have that quantity here. So maybe that's positive, and here's -4. Well, that -4 goes to the right, so we can't have that quantity here either. So something's wrong with our sketch. And what's wrong is, we don't know what quadrant this angle is in. It's obviously not in the first quadrant because all the quantities there are positive. So perhaps this angle should be over here in this second quadrant. So let's see here. Opposite here could be 5 because that goes upward. Adjacent here could be -4. Here's theta, and actually our reference angle would be down here. So this seems to fit. Tangent of theta equals -5/4. But it also says cosine of theta is greater than 0, meaning it's positive. Well, cosine is adjacent over hypotenuse. Hey, wait a minute. That adjacent side is negative. That can't be positive. So this is not correct either. So I've got to erase what we have here. And I've got to think where else we could draw this. So what I really should have done is plan this out a little bit first. Try to think this through. So let's see here. If tangent's going to be negative, opposite and adjacent must have opposite signs. So it could be either the second quadrant, which we know doesn't work, or this fourth one. So now I know for sure, hey, this angle is going to be down here in this fourth quadrant. I'm going to put theta prime, the reference angle here. Opposite could be -5, adjacent could be 4. Cosine in this case is positive. And there's one last quantity we need. We need to use the Pythagorean theorem to find this hypotenuse, which is the square root of 41. Now that we know where to draw this, so the tough part here is just figuring out where to draw this diagram. But now that we've got it, coming up with these answers is relatively simple. Sine is opposite over hypotenuse. And this quantity is perfectly correct, but sometimes it's easier to work with if we rationalize the denominator. Cosine would be adjacent over hypotenuse, and I will rationalize that denominator as well. Tangent, we're given in the problem, -5/4. And then we've got our reciprocals. So cotangent would be -4/5. And I always have students say, well, where's that negative? Shouldn't it be 4 over -5? And as long as you have one negative sign somewhere, it's the same quantity. Secant is the reciprocal of this quantity here, which is square root of 41/4. And cosecant is square root of 41 over -5. So coming up with a 6 answer is relatively easy. Coming up with a diagram, kind of tricky. So let's try one more of those. Cosine of theta equals 2/5. Now that would lead me to believe that the adjacent over hypotenuse would be 2/5. But then it tells me sine of theta is negative. So sine has to do with the opposite. That needs to be negative. So that means it needs to be pointing downward. So I'm going to do the same kind of triangle over here. I'll call this theta prime because that's the reference angle. I'll get rid of what we had up on top here. And now let me try to label the sides of this triangle. So cosine adjacent over hypotenuse is 2 over 5. Using the Pythagorean theorem, we can find this quantity here is square root of 21, but since it goes downward, it's negative square root of 21. And again, that's the tough part. Coming up with these 6 answers is relatively simple once we have that. So let me get these 6 answers here. And I will rationalize these denominators. Probably not necessary, but just realize these quantities are exactly the same. And there's our 6 answers. So on these problems, careful with your sketch. Once you have your sketch, coming up with the answers relatively easy. Here's the biggest mistake people make on these. It has to do with this sign right here. People forget to get those negatives for any quantity going downward or to the left. So make sure those quantities are marked negative on your diagrams. Okay, let's move on to a different kind of problem. Third example, give 2 values of theta that satisfy this equation. Give your answer in degrees and radians. So this is saying find 2 angles that have a sine of square root of 3 over 2. Now there's 2 ways to do this problem. One way is to try to make a sketch of this. Okay, so I'm going to draw a sketch, and I know sine is opposite over hypotenuse. So this is saying find this angle measure that has these values here. And if we think about our special right triangles, if I divide everything by 2, this looks a lot like one of those special right triangles. In fact, this angle here would be 60 degrees. Now this occurs in one other place as well. So if you think about, hey, it doesn't matter if this quantity here is positive or negative. If we think about another triangle going this way, square root of 3 over 2, it still goes up that amount. The hypotenuse is still 1. So this one here would be 120 degrees. Now here's a totally different way to do this. Totally different way. Take a look at your unit circle. And just look for angles on that unit circle that have a sine of square root of 3 over 2. Now sine is the y-coordinate on the unit circle. So find 2 angles that have a y-coordinate of square root of 3 over 2, and those angles would be 60 degrees and 120 degrees. Now we also need to find our angle in radians, so we need to think, okay, 60 is a third of the way to a straight line. 120 is 2/3 of the way to a straight line. But again, if you use your unit circle to find those answers, you can come up with those right away. Now careful, if you're just using your calculator to do this problem, so let me bring this over here, let me pull out my calculator. So I'm going to rewrite this as sine of theta equals square root of 3 over 2. Getting that theta by itself, taking the inverse sine of both sides, this works perfectly well, and it gives you the answer we're looking for. However, it only gives you one of those answers. So if you rely on your calculator, you might not get the entire story here. You might only get one solution. So just realize if we're looking for 2 values, calculator works perfectly fine, but then we have to either use a sketch or the unit circle to find our second answer. Okay, so let's look at one more example kind of like that. So cosine of theta equals negative 1/2. So again, we can use our unit circle, find 2 places on the unit circle where the cosine, which is the x-coordinate, is equal to negative 1/2. Or we can make a sketch. If I make a sketch of this, I have to think, okay, adjacent over hypotenuse must be negative, so these 2 triangles are going to go in this direction. Here's negative 1/2. Or I could have another triangle down here, negative 1/2. And I've got to think about my special right triangles and think about what this angle here would measure. Okay, if I do that, this angle is 120 degrees. Here's 60, here's another 60. So my 2 angles would be, theta could be 120 degrees, or it could be 240 degrees. Again, another way to do this would be to take the inverse cosine of both sides on your calculator. So if you do the inverse cosine of negative 1/2, it'll probably tell you this first answer 120, and just realize we have to use some method, either the unit circle or a sketch, to come up with the second answer. Now we also need our answers in radians. So 120 is 2/3 of the way to a straight line. 240 is another third beyond that. So 2 pi over 3 and 4 pi over 3. Okay, let's move on. So next example here, it gets back to that idea of reference angles. So I'm just going to make a sketch of this first. 213 degrees. We know 180 degrees is a straight line. So this is 33 degrees beyond that. So we're going to have this angle look something like this. Here's our angle theta. For these angles, always start on the x-axis at the right, always measure counterclockwise. So there's 213 degrees. Now the reference angle is this angle right in here, which I'm going to label theta prime. Remember, the reference angle always is the angle from the terminal side to the x-axis. So do not measure to the right or to the left. What would this angle be? Well, if 180 degrees is that straight line, 213 is where we're at now. So that's going to be 33 degrees beyond 180 degrees. So I'm going to say theta prime equals 33 degrees. Okay, let's move on past that idea of reference angle. Actually, whoops, same example, same kind of idea. So again, I'm going to sketch a 110 degree angle. So here's 90, a little past that is 110 degrees. So there's theta, which is 110 degrees. The reference angle is what we get if we drop straight down here, and I'll label that theta prime. Well, if we're 110 degrees, 70 more degrees would give us that straight line. So our reference angle is 70 degrees. Now the reason I've got two of these examples on here is because sometimes people get the idea of, well, you just always take your angle minus 180 or just take 180 minus the angle. And it could be one or the other, so be careful. In this case, it was 180 minus 110. On the previous one is 213 minus 180. So we have to be careful with what we do when, and if you make a quick sketch, it'll help you figure out what to do. All right, next one. Evaluate sine, cosine, and tangent of this angle without a calculator. All right, two ways we could do this. One way is to make a sketch of this. So 5 pi over 3 is going to be, okay, starting here, 1, 2, 3/3 gives us a straight line. 4, 5/3 is somewhere down here. So here is 5 pi over 3. Now, if I had to make a right triangle here, we know if we do that, we're 1/3 of the way short of a straight line. This is 60 degrees. We know the dimensions of these special right triangles. So I'm going to get those on here, being careful that, hey, this quantity goes down, so it's negative. And once we have that, we can say the sine of that angle, 5 pi over 3, is going to be equal to opposite over hypotenuse, or negative square root of 3 over 2. Cosine of that angle is adjacent over hypotenuse, and tangent of that angle is opposite over adjacent, which is negative square root of 3 over 1. Now, that's one way to do this problem. Here's another way. Grab your unit circle. If you look on your unit circle, once you know how to come up with the unit circle, it's a great tool to do these problems. Find 5 pi over 3. Your sine is the y-coordinate. And it makes sense it's the y-coordinate. It's this value that goes up and down. Cosine is the x-coordinate. It's this value that goes left and right. And tangent is y over x. We know tangent is sine over cosine. So if you have a unit circle, we don't need to make a sketch at all. We can use our unit circle to come up with these answers. So let's do one more just using our unit circle. 3 pi over 4. On your unit circle, 3 pi over 4 is right over here. That quantity right there is going to be negative square root of 2 over 2, comma square root of 2 over 2. So there's your point. The sine of this angle is equal to the y-coordinate, which is square root of 2 over 2. The cosine of this angle is equal to the x-coordinate, which is negative square root of 2 over 2. And the tangent of this angle equals y over x. Since they're the same quantities, one's positive, one's negative, tangent would be -1. So your unit circle is a great tool that you can use. In fact, that's why you even came up with it. In Algebra 2, you might have been told, just memorize this, you need to know it. Earlier this week, we came up with it on our own. This is why we have it, to use it as a tool to solve these problems. Okay, let's continue. So let's go back to some of these kind of problems. So find the indicated trigonometric value. We know the sine of theta is -5/13. We know theta is in quadrant 3, so I'm going to make a sketch of this. We keep seeing these same kind of problems because, hey, these are important problems. Guess what? This is something you need to know. Make a sketch in quadrant 3. Label what you know. Sine is opposite over hypotenuse. Use Pythagorean theorem to find the missing side. Be careful with those positives and negatives. Once everything's labeled, tangent of theta is opposite over adjacent, which you can simplify as 5/12. All right, a couple more examples and we'll call it a day. This says find the indicated trigonometric value in the specified quadrant. So it's saying the tangent of theta is -4/3 in quadrant 4. So I'm looking down here in quadrant 4. I'll get a sketch of this angle. And we know tangent, which is opposite over adjacent, is -4/3. Pythagorean theorem tells us the missing side. Since it's the radius of a circle, it's always a positive quantity. Sine of that theta would be opposite over hypotenuse. And there's your answer. Once you have a sketch, coming up with that answer is relatively simple. All right, last kind of problem we're going to see. Find two solutions of the equation. Give your answers in degrees and radians. Here's my suggestion for you. Let's just use our unit circle. So to find these two solutions, cosine is the same as the x-coordinate. So on the unit circle, find an angle that has an x-coordinate of square root of 2/2. You'll see that angle's at 45 degrees, which is the same as pi/4. Find another angle that has an x-coordinate of square root of 2/2. You'll have to go all the way around the unit circle. In fact, here's the two places they're at. One's right here at 45 degrees. The other one's down here at 315 degrees, which is the same as 7 pi/4. So using your unit circle as a tool comes up with these two answers relatively quickly. So one last problem like that, tangent of theta equals -1. Now think about this. Here on the unit circle, we have to find where y over x is -1. So basically, x and y have to have the same quantities. One has to be positive, one has to be negative. You will find those at this spot and at this spot. One of those angles is 135 degrees, which is the same as 3 pi/4. One of those angles is 315 degrees, which is the same as 7 pi/4. So feel free to use your unit circle to help you out with these kind of problems. It definitely will assist you and make your life easier. All right, we've got an assignment on page 294. Check this out. When you're done with this, move on to your next set of notes.